K tutorial number 4, defining int++, lesson 5. In this lesson, we will see how easily we can delete, save, and/or restore contents of cells in order to achieve the desired semantics of language constructs that involve abrupt changes of control or environments. We have seen similar or related K features in the Lambda++ language in tutorial 3. Recall that program sumio.imp got stuck with a halt on top of its computation. Let us start by adding semantics to the halt statement. As its name says, what we want is to abruptly terminate the execution of the program. Moreover, we want the program configuration to look as if the program terminated normally, with an empty computation cell. The simplest way to achieve that is to simply empty the computation cell when halt is encountered. It is important to mention the entire K cell here, with both its membranes closed, to make sure that its entire content is discarded. Note the anonymous variable, which matches the rest of the computation. Compile and krun sum-io.imp. Note that unlike in lesson 4, the program terminates with an empty computation cell now. As mentioned earlier, the semantics of blocks that was inherited from imp is actually wrong. Program locals.imp shows it very clearly. The environments are not correctly restored at block exits. One way to fix the problem is to take a snapshot of the current environment when a block is entered and save it somewhere, and then to restore it when the block is left. There are many ways to do this, which you can explore on your own. For example, you can add a new list cell for this task where to push-pop the environment snapshots in a stack style. Or you can use the existing environment cell for this purpose, but then you need to change the variable access rules to search through the stack environments for their variable. My preferred solution is to follow a style similar to how we saved restored Lambda++ environments in tutorial 3, namely to use the already existing K cell for such operations. More specifically, we place a reminder item in the computation whenever we need to take a snapshot of some cell contents. The item simply holds the entire contents of the cell. Then, when the reminder item is reached, we restore the contents of the cell. In our case here, like in tutorial 3, we define an item construct env, which holds a map, and we use it to place a reminder in the block rule to restore the environment map when the enclosed statement is done. The only thing left now is to give the definition of environment restore. We are done. Compile and krun locals.imp. Everything should work correctly now. Note that the rule for environment restoration is different from the one we had in Lambda++ in tutorial 3, in that there is no value preceding the environment restoration item in the computation. That's because int++ statements, unlike Lambda++ expressions, evaluate to nothing. In the next lesson, we will give semantics to the spawn of s construct, which dynamically creates a concurrent shared memory thread executing statement s.